So I've decided to talk on what GeoPrisms does, and we are kind of working right now. We have upcoming activities in the Alaska and Aleutian subduction zone, and mostly on the Aleutian volcanic arc. Right. So, this is a screenshot that I took from the IRIS website, from their Seismic Monitor. I don't know if you ever heard about this tool. It's free. It's public access. It's very neat. It's a very nice way to locate all the earthquakes that happen, instantaneously. So, give you an example. In red, so I took the screenshot last Thursday. So let's say we are last Thursday. In red are the earthquakes that happened today. And I think in orange was yesterday, and in yellow those past 2 weeks, and in pink those last 5 years. So my point is the need to show you that earthquakes happen every day. And you can see that they define what we call the tectonic plates. I didn't put down the URL, but I think you can type on Google Seismic Monitor IRIS, and you will have a direct link to this interface. And you can click on the earthquakes, and you will have the ID of each earthquake. So that's really neat. I believe that everybody wants that map. It's the representation of what we know as plate tectonics. So when you have rigid lithosphere riding over the convecting mantle, and as the plates move, you can see that their boundaries acting 3 different ways. You have transform boundaries when the plates slide past each other, like the San Andreas Fault. You have divergent boundaries when they move apart, like the mid-ocean ridges, or in the case of the GeoPrism studies, the East African Rift System, or the Eastern North American Margin. And we have a third kind of boundaries, the convergent boundaries, also called subduction zones, where the plates move towards each other, like the Aleutian, Alaska and Aleutian subduction zone. And I'm going to focus there. In US, we have 2 convergent boundaries. We have Cascadia, where the Juan de Fuca plate is subducting beneath the North American plate. And you have the Alaska and Aleutian subduction zone, where you have the Pacific plate subducting beneath the North American plate. And those 2 areas have been defined as high priority by the GeoPrisms community. So in the configuration of Alaska and Aleutian subduction zone, you have a piece of oceanic lithosphere subducting beneath the Pacific plate. And in this configuration, you have the formation of a volcanic arc that is set up very close to the trench and parallel to the trench, like the Aleutian volcanic arc. I don't know how many volcanoes you got on the Aleutian arc. Does anybody know the number, the actual number? So that's a lot. Now, let's have a closer look to a subduction zone. Here you have the Pacific plate subducting beneath the North American plate. As the plate is going down, the water in the sediments a part is going in the mantle, and another part is going to be released in the overriding mantle, and is going to induce what we call partial melting, which is the origin of the volcanic activity. And the Aleutian arc is known as one of the most active volcanic active zones around the world. And this is important because, as you may know, we have a lot of air transport pathway going, the Aleutian arc. And what happened in 1989, you may know better than me, but the Boeing 747 has been forced to land in Anchorage Airport when its 4 engines failed after it flew through a thick cloud, ash cloud. So that's very important to understand the arc volcanism, and to interpret it. You got also, as we saw yesterday, mega thrust earthquake that can happen at the interface of the two plates. And these are known as the most powerful earthquake that happen around the world, like the one that we saw yesterday, magnitude 9.2. And then both volcanic activity and earthquake that can trigger landslides onshore and offshore. And they can occur. I'm so sorry, I'm so tired. You can have tsunami. Yeah, that's the point. That's the idea. And I talked about that yesterday, and Emily and I were kind of skeptical, but apparently in 1958, a magnitude 8.3 occurred and triggered a landslide of 30 million cubic rock under the Lituya Bay that created a wave run-up of 500 meters. So have you ever heard about this story? And so 500 meters sounds like a real number, because I read it everywhere. But it's kind of incredible. It's taller than the Empire State Building. So you just imagine a side of the Empire State Building coming up, and you're like, what's going on? So anyway, that's why it's important to understand the factors that control the creation of earthquake, mega thrust earthquakes, and arc volcanism. So the GeoPrisms community, they gathered, we organized a couple of workshops and meetings, and they found the key unknowns that fall under the subduction cycles and deformation initiative. And those key questions, I just put some of them, the most important. Define the physical and chemical properties of volatiles released through the subduction, how the volatile affect the plate interface, also what define the size, the location, and frequency of great subduction, mega thrust earthquakes, etc., etc. And that will help to improve fundamental scientific understanding of some of the most destructive natural hazards on the planet. So we just get back this report from one of our GeoPrisms fellow. You may know her, some of you may know her, it's Taryn Lopez. She's a postdoc at University of Alaska Fairbanks, and she has been funded last year through the GeoPrisms NSF postdoctoral fellowship. And I brought a copy of the report there, so you can have a look. And if you would like to receive the newsletter, just let me know, give me your address, and I'll be very happy to send you a copy. So Taryn conducted, you'll see later, but Taryn conducted a 2-week campaign in the Katmai volcanic cluster, and it's kind of very cool study. So fluids that are present underneath the surface of the volcano can trigger earthquakes, abundant seismicity, and those fluids, magma, volcanic gases, and hydrothermal waters, currently you can't determine the nature of the fluid with the seismic data. But it's very important to know what kind of fluids you have underneath a volcano. So that's the idea of this project, is to combine gas composition, measurement of gas composition, and seismicity to find the unique seismic signatures that going with the nature of the fluid. And so combining gas, a measurement of gas composition, and seismic data can help to determine when the next eruption can occur and their explosivity. So she conducted a 2-week campaign in the Katmai volcanic cluster, which is 300-something miles southwest of Anchorage. Here is a closer view of the Katmai volcanic cluster. She works on 3 volcanoes, the Trident, the Mount Martin, and the McGeek. So just to give you an idea, this is the Katmai, this is the Nova Rupta that erupted in 1912, and the Valley of 10,000 Smokes. So this is the southern tip of the volcano, the 10,000 smoke. This is the caldera of the Katmai that is filled by a lake. It's about 3 miles diameter, and the volcano is about 10 miles diameter, just to give you an idea of the size of those volcanoes. So she conducted this field campaign in last July. So her team and Terrain managed to collect samples of volcanic fluids. They managed to hike down the crater of Mount Magic. The instance over here, you can see one of her colleagues sampling fumaroles. This is, I think, the crater of the Mount Magic. And they also installed instruments to measure seismic data and gas composition. And I think this is on the Mount Martin, looking over the Mount Magic. Am I right? I think so.
Oh, I've never been on Martin, but
it looks like that. Okay, good. So why I decided to show you this study first, because it's fresh. I mean, we just received that a couple of weeks ago, and we are kind of exciting. Second of all, it happens, and it's very challenging to work in that environment. And even if you are well prepared, it took them months to prepare this field campaign. They had something like 600 pounds of gear, materials, food, etc. They were prepared, but you can't decide either or not you're going to have troubles in that kind of environment. So they came back, so they led the instruments on site in July, and they came back in September with 2 colleagues to retrieve those instruments. And the weather conditions were perfect for that kind of experiment, but the weather conditions just changed in an hour, from clear blue skies like what we had yesterday, from very thick wall of clouds and freezing rain. And they had to, it forced them to go back to the helicopter, but it was even too late. The rotor blades were all frozen, so they had to stay 2 days stuck in the helicopter on Mount Magic. Fortunately, the story ended up pretty well. They had been rescued after 2 days. They were prepared. That, I think, saved them, or maybe saved their fingers or their toes. So just to show you how challenging it is to work in the Aleutian Islands. So one logistical challenge is the climate, you understood. But there are many other challenges, and one of them is the size. The Aleutian arc is around 2,500 kilometers long, if I'm right. And this is the Cascadia subduction zone, just to give you an idea. So GeoPrisms works also there. It's more than 3 times Cascadia, so imagine. And it's very long, and it has also very small dispersed population centers. So that's kind of problematic for researchers that are going there, for buy food or for the fuel or whatever. But a lot is going on in this region, and a lot has been already done. On-land mapping, ocean surveys, drilling, and EarthScope is very active in this region, if you didn't understand. There is the deployment of the TA coming up. So we have lots to do. There are a lot of interesting things coming up in the next months or years. So we just had the review of the solicitation for GeoPrisms, and NSF will support logistics for a big community effort that will happen in summer 2015 and 16, 30 days in each season. The idea is to bring all together, scientists from different horizons working on physics and chemistry on the boat, on the research vessels. We'll have helicopter for the deployment of, seismic, geodetic instruments. Researchers will go on land to sample some rocks, And so that's the idea now. We are here. We will have more information coming up. So we are pretty exciting in GeoPrisms. It's going to be a huge community effort with open access data. So that's kind of exciting. So if you want more information about that, I invite you to go on the website. We have more coming up in the next months, next year. Don't forget, if you want to receive the newsletter copy, just give me your address. I'll be happy to send you a copy. And also, you can sign up for the listserv and follow us on Facebook and Twitter. We have lots of opportunities, maybe not directly for you guys, but on the website we have a couple of material that you could use. Public lecture from our distinguished lectureship speaker. So if you want to, to learn more about GeoPrisms. So thank you.